There's something called moral responsibility. There's two things, remember. There's something called ethics and something called morals. All right? Those are two different concepts. I want you to just jot down in your exercise book, what is the difference between ethics and morals? All right? Ethics and morals. All right? I want that to be a self-study exercise to help you with your short test number 2. What is the difference between ethics and morals? All right. Okay. Okay. Now, accountability for the now, the future, and the past. Okay. Now, first thing. Remember, let's look at the title of the topic. It says moral responsibility in engineering. Moral, and there's one important word. The second important word is responsibility. Now, this ties into our very first lecture when I came in and we spoke about professionalism. What is one characteristic of a professional? I mean, there's several of them, but what is the one which is ties into this one here? You know how there was one with, I don't know, it was number 3 or number 4, somewhere around there. Professionals take responsibility for their action. Professionals take responsibility for their actions, right? So they take ownership. There's one word. Remember there was one slide covering ownership. They take ownership for their actions. Then there was another slide saying they take responsibility. Ownership means when they do a project, the professional advertises, hey, I'm working on this project. They don't do it secretly. They don't do it secretly. Professional would outright advertise that, hey, this project is mine. I'm building the U8 lecture theater. Or I'm renovating and putting in a new IT system, auditorium system for the U8 lecture theater. That's what a professional would do, right? And then, if something, God forbid, if something goes wrong, something works out, they take responsibility. They'll say, okay, don't worry. I designed that particular audio system. If it's not functioning correctly, I'll get it corrected, right? That's responsibility, all right? So there's two things. They take ownership, which means they advertise, they don't shy away from the fact that it is them who are doing it, doing that project. And responsibility means if something goes wrong, they take care of it. All right. Now, but responsibility comes with a lot of burden. That's another word. Burden may sound like a simple English word, but burden in a legal sense of view is a very important concept. All right. The word responsibility. Let's go step by step. Let's have a look at the word responsibility. Responsibility is the state or fact of having a duty to deal with or something or having control over someone, right? Responsibility. If you are responsible for your assignment or your project, if you are responsible for your little brother, or if you are responsible for your wife and your children, that means you have a duty. That's another legal term. Duty. You have a duty to deal with. Now, another definition in terms of engineering is responsible conduct is expected by engineers in public, right? An engineer, when they are walking around in public, they are required to be responsible. So, for example, I'll give you an example of myself, right? This happened earlier this year. I was driving down Lodala Bay Road, and I don't know for what reason, the wire line snapped right in front of me. So, maybe 10 meters out, right? So what was the first thing I did? I did not just dodge the car in front of me. There was one taxi in front of me, and then there was another car in front of me. So I was the third car from where it snapped. The taxi dodged it and took off. The car, private vehicle, it was a 4-wheel drive. It took off, right? What I did was I pulled my car onto the side of the road, called the emergency number. And this is the funny thing. I called the emergency number. I had a Digicel phone. And I said, hey, there's an electrical emergency here. There's a wire, a live wire which just snapped in the middle of Lodala Bay Road. And this was right in front of USP, in front of Costules. And the live wire is still, shivering on the road itself. Now, funny thing was, he said, okay, why don't you call this number, 914, that's electrical emergency. I called 914 and the operator says, sorry, you've got a Digicel number. You've got a Digicel number, you need to call me from a Voda or Inc number. And then I said, hey, look, there's an electrical emergency, we deal with the Voda and Inc part later, all right? This is an electrical emergency and you will deal with it later, right? And then maybe exactly 20 seconds later, 917 calls me again. Sir, where is the emergency? So I tell them, hey, it's right in front of Loyola Bay Road and I'm parked over here. And they said, okay, we're dispatching FEA team right now. So my point here is, apart from the side story about the mess up with the operator, is that if there is some kind of mess up, and let's say you didn't do that project. Let's say, obviously, I didn't put up those wire lines, right? Okay? But as a human being, as an engineer, you have knowledge that hey, that live wire can cause death or serious bodily harm or injury to a person. So what do? You don't just dodge it. You just say, oh, a big problem in the Pacific is that people, they shy away from responsibility. As engineers, you should move towards responsibility. Don't shy away. The biggest problem in the Pacific, in our culture, in our inert culture, is we have this attitude of, in Fijian, they say, oh, Vitalia, just never mind. Somebody will take care of it. Those guys will take it. You're not responsible for that. Just leave it. You're not paid for that. That's another common sense. But, where there is safety issues involved, where there is a loss to the environment. Like, for example, another one is, you may see a burst water pipe you're driving along the road, and you see a burst water pipe. The right thing to do is to call the authorities, let's say, I think it's water authority, and tell them there's a burst water pipe. Don't leave it to some other guy. A lot of people have this particular type of attitude where they say, oh, just leave it, somebody will complain, or they've got trucks going around and they'll know where the burst is. But as an engineer, right, you've got to care for infrastructure damage, you've got to care for electrical damage, utility damage, right, around where you are living, all right, okay? And if you see there's something where you can help out by informing, because you're not going to be asked to go and repair that burst water pipe or asked to climb on the pole and repair that particular broken live power line. No, you're not going to be doing it. All you're going to do is pass the information. And this passing of the information is part of your responsibility as an engineer. All right? Okay. Now, the next part is responsibility. If you are a member of a team, all right, you are still responsible. Let's say you work for a firm, an engineering firm, and that firm messed up, all right? But because you're a member of that engineering team, you are still responsible. And you should not shy away from responsibility. All right. Now, the next part is responsibility has to do with accountability. Now, that's another term. So when something goes wrong, this is your project, this is not FEA or somebody else's project. When something goes wrong in your project, you are accountable. People may come back to you and say, hey, we're going to take court action against your company, or we're going to, if it's your company, if you own that company, we're going to take court action against you, right? Okay, and there's another lecture where we'll deal with how you remedy against that. Doesn't mean that you now stay scared and say, I'm not going to take on any big projects, because if I make a mistake in that big project, those customers will come back and sue me. No, there's a way to remedy that. There's a particular technique which all engineers do to remedy that, all right? Okay. As we will see, accountability, and there's another word, blame, right, are core themes with legal and moral implications. All right. Now, there are standards of conduct in engineering, right? I'm not going to read that entire paragraph. I hope that after our lectures, you get a chance to print out these lecture notes, or okay, if print out too expensive, I hope you get a chance to download these PDF files, they're all PDF files, onto your mobile phone, and have a read of them, all right? Okay, have a read of them. I have a habit of not reading word for word from the lecture slides. That's for you to read. Okay, there are standards of conduct in engineering. Now, let me just go one step back, and if we go to our FIE over here, somewhere there is something called the Code of Ethics. All right, why did this happen? All right. Okay, there's something called the code of ethics in engineering, code of conduct, and one of the major part of it is, as usual, there's honesty, integrity, there is responsibility, and so forth. Okay, now there are certain standards which you are required to uphold, right? You cannot be caught lying, all right? Now, as we move on, when I spoke about some of those words, there are some qualities of an engineer. Now, these are some qualities. There's integrity. Integrity means when somebody, you should know the definitions of each of those words, all right? These words sounds very simple. They, because you guys are final year engineering students and you've done a lot of reading over your last 4 years as well as prior to engineering, you were in secondary school. Some of these words may sound simple, but what is different in this course is that you should be able to link it with the engineering context. Now, what does it mean when there is integrity? That means, let us say, if somebody came to you and said, hey, somebody mentioned that this truck is supposed to weigh 3 tons, right? Okay? So if you do your calculations and measurements as an independent engineer, right, independent of the customer, you should give an answer to which your client should be able to rely on. So if you as an engineer do calculations and say, hey, this truck weighs 3 tons, maybe you weighed it, maybe you did some other way to find the weight, right? Then your answer should be within the expected experimental uncertainty, all right? All right, now there should be a willingness to make self-sacrifice. That doesn't mean you go and do, what do you call, a kamikaze, or, you know what a kamikaze is? Okay, in the Second World War, Japanese air pilots, right? They used to, Japanese Air Force pilots, I don't know the exact Japanese name. So Japanese Air Force, if they would run out of bullets, right, to shoot at a naval plane from the opposing force, their last ditch would be they would crash, they would commit suicide, and they would crash their plane into, let's say, an American Navy ship. So that was called a kamikaze assault, right? But hey, you shouldn't do that. That's called self-sacrifice. We're not expecting you to go and kill yourself over being an engineer. Self-sacrifice means to spend the long hours and the long nights and the long days to get the correct answer. This is related to integrity. Sometimes a lot of people, especially students at this stage, they take shortcuts and they do estimates, and sometimes estimates can become wrong and it can result in huge errors. A good example is the M8CC building. Now there should be perseverance. Perseverance means you have to endure. Now there should be basic competence, engineering competence, and you should be able to see the big picture. Honesty, ability to communicate clearly and informatively, committed to objectivity, imaginative, civic-mindedness, open to acknowledge and correcting mistakes, work well with others, committed to quality, etc. Now these qualities, okay, so so these qualities contribute to our code or standard of conduct. All these qualities which we have mentioned, they form our standard of conduct, right? The standard of conduct is not just one thing. It's not just saying, oh, he's an honest guy. A person can be honest, but he can make lots of mistakes in his calculations, and they can be honest mistakes. You get what I'm saying? There can be such things as honest mistakes, but that doesn't mean, what it means is, it doesn't mean he's a good engineer because he was an honest man. It means he's an incompetent engineer. If a person is an honest person, whatever he says is the truth, he doesn't steal money or do any under the table or any corruption or anything, but he makes mistakes, honest mistakes in his calculation and design. All that is saying is that he's incompetent. He hasn't mastered the basics. All right? Okay. All right. Professional behavior exhibited over a broad spectrum. All right? At one end, do as little and get away with a complete job. Remember, you will have a lot of demand in your particular field, right? So you are required to do as little as possible, little meaning little time, to get away with a complete job. And on the other hand, you must be committed above and beyond to the call of duty. You should be exemplary. Most of use of conduct ourselves somewhere in between, right? So you have to balance the scales. You can't be doing just like a 5-minute job or 1-hour job to get 20,000. On the other hand, you can't be dedicating your entire life and neglecting all the other projects, right, to get that 20,000, which is small money in terms of engineering. So you should be somewhere in the middle. You have to balance it. All right? Okay, now let's look at now, there are certain standards. These are written down standards. There's standards of competence. There is another thing called standards of competence is related to your studies. How much studies have you done? Have you got a BE? Have you got a BTech? Have you got a diploma? Have you got a master's? Right? What certification have you done outside? Like, for example, anybody know what's the certification for refrigeration? There's an international certification for air conditioning and refrigeration. Try and find that out. Right? Okay. The electrical guys, do you know what's the certification if you want to do electrical works from FEA? This comes from FEA. Wireman's license. And if you want to now do repairs on the power pole, like if you work for an electrical contractor and you required your company has been given the contract to do some repairs on a fallen power line. What's that one? Called a pole license, right? There's all these other forms of licensing. Similarly, for refrigeration, for air conditioning, there's international standards, all right? Okay, now, those are standards of competence. It means how much knowledge you have and hands-on experience. There's technical or regulatory standards. So, for example, the easy one. For Fiji, if you want to build a building, if you want to build a house or even a big building, what do you follow? The building code. Yeah, have you heard of this? The building code, right? So that you certify it to a particular standard, right? Similarly, there's other codes as well. There's the ASME code. So if you want to look at whether a particular steel is meeting a particular standard or not, all right. Then there's standards. So remember, there's 3 types of standards. One is to do with competence and knowledge. One is to do with industrial standards, right? So ASME, the Wireman's License Code, all these things, right? Now, the third one is standards of moral responsibility, right? As expressed by the Engineering Code of Ethics. So FIE has also got, FIE, Fiji Institute of Engineers, has also got a moral code of engineering, right? And I've got it up there. I just got to unhide it, okay? And there's certain things which you've got to adhere to. Now, the establishment of these standards typically contributes towards professionalism, right? Now, generally we try to follow those standards. Now, about a month ago, I went and attended, remember, I mentioned to you last week, when you become a member of FIE, right now we're just filling out the forms. I'll go and submit your form and your subscription money to that, and then they'll start inviting you to there's going to be about 3 more this year, what they call professional development sessions. So that'll be free for you, no entry fees required. You're a member, you'll just say, hey, I'm a student member. You'll go, you'll eat, you'll drink, you'll attend those sessions, you'll mix around with all your fellow engineers, right? You'll mix around with all these fellow engineers, you know, that more cements your position next year when you're looking for a job. Now, the point is that with regards to these sessions, I went to one about a month ago. It was called, basically, it was on standards of steel used in construction. And the engineers who designed the big monster building on McGregor Road, it's called the WMG Tower. You guys, WMG Tower? Yeah, WMG Tower. So the engineers were defending themselves on their design process because they use, this is the problem, this is a real engineering problem. They used Chinese steel. There's nothing wrong with Chinese. Yeah? Okay? You ask Yahya. Right? Okay. Okay. Now, there's nothing wrong with Chinese steel. Now, it's only a matter of that the Chinese steel, the certificates, you know, the miller, how steel is made, you take ore, you take it to a steel mill. The steel mill, they'll do some processing. You guys did a bit of, mechanical engineers did a bit of material science, right? Okay? There's certain standards you've got to meet. So especially for the mechanical guys, you guys will know the strength, the ductility, the shear force, the bending moment, all these sorts of things. All right, now, the Chinese certificates are made in English, and they've got Chinese as well in English translation, right? But they use certain other descriptors. So for example, the Australia-New Zealand standard, ANZS standard, NZS standard, they would say the shear force with 1,000 kilonewtons of force resulted in so much. With the ductility is with so much and so much, right? But the Chinese one was made using different units, different units and different values. So now you have to take the Chinese standard, and the problem is the Fiji building code uses the NZS and the American standards. Either you have a choice. You can use the NZS, the Australia-New Zealand standard. When it comes to steel buildings, it's all a steel building, right? Or you can use the American standard. So what the engineers did was they had to match those Chinese certificates, the miller's certificate, to see whether it will fall, those steel will fall in grade A or grade B or grade C, right? And for a building that tall, right, and with that bearing and that load, that wind force, you know, remember we've got a lot of salty air, right? That particular standard has got to be A grade. So they had to prove that this can meet A grade standard. But there's another problem. The Chinese certificate did not mention certain things. Certain things which are, let's say, temperature, resistance to corrosion, you know, right? It does not mention it in its particular certificate. It mentions variable A, variable C, variable D, variable E, but missing variable B, which is there in the NZS standard. So where you get it from? So they had to cut pieces of steel. There's no lab in Fiji. They had to send it to Australia, and they had to send it to another place, two places, one in Singapore, one in Australia. Two independent labs had to test that steel to now reflect that particular standard, right? So this is real life problem. We have to follow certain standards, some regulatory standards. So remember, there's three different standards: standards of competence, standards of moral responsibilities, and there's regulatory standards. All right, I'll give you a chance to read through this on your own. Now, let's come to responsibility. Now, if that engineer, if he says, hey, let's just hide this under the carpet, we know it's Chinese steel, it'll work. Everybody else is doing it. And this was the excuse they were trying to make early on, until the government stepped in. The reason they were giving was, listen to this one. The engineer was trying to say, yeah, okay, they said this. They said, look at China. They've got really tall buildings. They use Chinese steel. No problems there. They were saying, if you look at China and look at Beijing, look at Shanghai, they've got a valid point there. They're all using Chinese steel in China. There's no problems there. What do you think is going? It shouldn't be any problem in Fiji then. But you see, when you're an engineer, you can't just make a broad understanding like that, hey, in Shanghai and in Beijing, in Hong Kong, all those tall buildings, 100-story buildings, use Chinese steel and there should be no problem. You can't make that assumption. Why? We're in a different environment. We are in a different environment. Our plate tectonics, you know what plate tectonics is? The amount of earthquakes and tremor in the ground. The amount of humidity and salt in our atmosphere, especially in Suva, right, which is right facing that sea, is totally different, right? And also our workmanship level is different as well, right? There's all these things. So you can't make some assumption that, hey, the building next door used it, so we should be able to use it as well. You can't make that particular broad sort of thing. They can help you up in the initial case, but eventually you do have to meet the standard, right? That's why the government stepped in. If you follow the news, the government stepped in. There was a stop work order. The steel samples were sent for testing. They came back. They passed. I think there was a bit of competition as well. Some of the local vendors wanted to sell their steel as well. But by the way, to be honest, the local vendors were also importing Chinese steel, so it wouldn't have made any difference. All right, I think it was Manubai or someone. All right, okay. So, so there you go. Right, now, if something would have gone wrong, there's something known as obligation responsibility. Let's look at the levels of responsibility. The first thing is called obligation responsibility. That relates to a person who is a supervisor, a supervisory role, responsible to ensure work is conducted in accordance with professional standards. So if you're the building, if you're the engineering manager or the project manager, you have an obligation. You have to ensure that this happens, all right? You have to be accountable, and you have to be positive, and you have to be forward-looking towards your responsibility. It means that you have to plan ahead. You have to plan forward. You can't be stuck in the past. You can't be saying, hey, let's change that still now. We'll see what happens later. If they catch on to us, then we'll change it. But if they say nothing, then we'll just move. No, you can't be that way. You have to plan forward. All right, now, the other type of responsibility is blame responsibility. Blame responsibility is when an accident occurs, when a mistake or an accident occurs as a consequence of engineers' actions or inactions. All right, this is the hard part. All right, and this can refer, this can result in certain consequences. The first one is being to blame, which means, yeah, you can get terminated for your job. And the second one is it is negative. The second description is that it is negative and looks backwards. Now let's look at it in detail now. Now, obligation responsibility. When regulations and standards relating to procedures are insufficient to complete a job, solution does not quite align with the available standards. That's the word I was looking for. The Chinese standard from the miller's documents, right, was not aligning to the ANZUS and the ASME standards. So they had to use some other calculations to prove that, yes, that steel was worthy, right? Due to unforeseen situations, when unexpected problems arise, right? Like sometimes you may be following a standard, but because the cyclone was not planned for, right? There may be there's certain things which was not planned for. There may be some results in some issues. So that's where obligation responsibility arises. Or if a product cannot be designed to absolute safety, perhaps functionally impractical or economically impractical. Engineers then are expected to satisfy a more demanding norm, the standard of care, all right, which falls within the scope of moral responsibility. Application of professional codes of practice and professional judgment is required. All right, now, standard of care, it cannot be clearly defined here, all right? It means you've got to, there's certain projects where you won't be able to get a very clear answer. So you've got to apply a standard of care, right? So is it economically possible? You can't be spending $1 million on a little vehicle, right? Or is it, will there be safety implications and so forth, all right? Okay, now, that's obligation. Now, the word standard of care. Defining standard of care, best considered in context of legal issues, right? Let's read through that paragraph there. An engineer is not liable or responsible for damage for every error. Not for every error. Society has decided through case law that when you hire an engineer, you buy an engineer's normal errors. There are certain errors which engineers make, right? Which this comes in line with the experimental uncertainty. However, if an error is shown to have been worse than a certain level of error, then the engineer is liable. Okay? Right? If it is severe error. That level is the line of non-negligent and negligent error. And that is the standard of care. Okay. Now, what is the line? Okay, you can have a look through this paragraph. I want to go through this particular important part over here. So please, just write down in your exercise book that there's something known as standard of care. How does it tie in with obligation responsibility? And then we come to blame responsibility. Now, blame responsibility, because we've got about 5 to 10 minutes left, blame responsibility is when you have is when something goes wrong. Obligation responsibility, it will go to a civil court case. It will be more like a civil court case. You may get sued if something goes wrong. And to prove that you had an obligation responsibility. Let's say if you were supervising a project and something went wrong, but you have an obligation to look over all the little contractors. Now, blame responsibility. Blame responsibility is when you can be divided into 3 parts. Malicious intent, recklessness, and neglect. All right. Now I want to differentiate between the 3. Now, malicious intent is deliberate. It is deliberate. All right. Okay. You guys can. I'll encourage you to go through the slides again. Maybe download it onto your mobile phone and read it through it again. I'm skipping through some of the lines over there. All right. You've got to read through it. Try and understand it further. Now, there is an intent to do harm, right? There is an intent to do harm. Like, for example, maybe you were being underpaid. You are being underpaid by your boss. So what do? You deliberately design the system or design the wiring or such that you know it will collapse or it will break down later on. You build the let's say the conveyor belt system in some factory such that you are aware that that conveyor belt will stop working, right? And there's a lot of problems in FSC. There's a lot of malicious intent. That's one of the problems, major problems they had. A lot of, even though the managers were okay, the chief engineer was okay, but there is a malicious intent. Not to harm some person as an individual. But what was the malicious intent? So let's say the junior electrician or the fitter and the worker, what they do is they deliberately do something, let's talk about a conveyor belt. So to ensure that the conveyor belt will break down on the 3rd day of crushing. Why? Because they can then wake up all night and repair it and claim overtime. Right? This is well known. Right? You'll see that the mill always breaks down during the crushing season. Right? Why? Because somebody's claiming overtime. That's malicious intent. The only problem is that they haven't been able to find who was responsible. Right? Somehow or the other, mysteriously, every year, no one is charged. Right? Okay. But you as engineer, so that's the thing. Malicious intent is deliberately under-designing or deliberately making a mistake so that something breaks down. All right? Now, or let's say you know you don't like some guy, he stole your wife, and then what do? You deliberately alter some safety switch or something, right? Alter some safety thing so that when he goes and uses the welding machine, he gets burnt. All right? So that's deliberate. That's malicious intent. Right? Basically, if a project breaks down because deliberate action. All right. Now, serious breach of moral responsibility. That's a serious breach. And you can go to jail for that. It doesn't matter he banged your wife. But if he dies, you'll get charged for murder. All right? Okay, the next one is recklessness. All right, maybe we'll continue some of this in the next lecture. I'll just put it in summary. Recklessness is, and we'll discuss more later, is when, so we'll discuss this either on Wednesday or Thursday, is when you have a situation whereby we have, you have a project due and you did a careless job on it. In our layman's term in the South Pacific, they say careless job or very quick job. You didn't carefully do it, right? You did it in such a hurry that you know it was full of errors, but you just wanted to get rid of it, right? And we'll discuss more of it. The last one is negligence. Negligence, right? The last one is negligence. Negligence means that you didn't take the standard of care required, all right? All right, guys, this is a longer lecture. We'll continue with it, but for now, I think that sets you up. I think there's only 2 more slides left, and case 1, 2, and 3 is part of our labs this week. So let's just go through our labs. Our labs would be, you're required to look at one of those videos and then answer the question. And very shortly, I'll place the tutorial over here as well, the tutorial for this week. All right, guys.